Hey folks, it's Osiris. So this is just going to be a real quick kind of overview. I wanted to follow up on what I had talked about earlier, which was quantum computing, and kind of wanted to try and explain a little bit better and try to pass on to you why I'm excited about it and why I think that it's going to change everything. I'm going to go ahead and provide a link below to a better and animated explanation of what quantum computers are. And also, I'm not going to go into superposition and its exponential amplification of quantum computer powers because it's going to make your eyes glaze over. And also, honestly, it's not even the part of the quantum computer process that I'm most excited about. What I'm most excited about is quantum entanglement. So that's what we're going to get into here. And the rest of the quantum computer process, yeah, it's also really, really cool. But I just think just the quantum entanglement piece is enough to change everything. And hopefully by the end of this quick video, you will agree with me. So what is quantum entanglement? Einstein called quantum entanglement spooky action at a distance. And so basically what it is it's two particles that are entangled, and what influences one influences the other. And that process happens instantly, which means faster than light. And that it happens regardless of how far apart they are. Now, right now, we're kind of just at the beginning of the process of delving into quantum bits, which is a computer bit that is made out of these quantum entangled particles. But this bit can process things instantly, which is pretty impressive. And in order to kind of give you an idea of why that is impressive, I'm going to kind of talk a little bit about superconductors. So since the beginning of computers, scientists have been trying to create superconductors. And a superconductor is usually a metal, usually a higher grade metal. Most of your house is done with copper, but you can also you can make wires out of silver, you can make wires out of gold, you can make wires out of platinum. These higher these higher end conductive metals with a more dense electron cloud tend to conduct better because the electrons can easily pass from one to the other. And then in addition to that, they often will freeze the metal down to as close to absolute zero as they can in order to create this superconductor. And what's the goal of that? Why does that matter? Well, because a superconductor means that there's no resistance in the line. There's no resistance in the wires, which means that if there was really no resistance, that the electrical signal could travel at the speed of light, which is very fast, 186,000 miles per second. A lot of times, the electrical signal in your computer is actually traveling, between a quarter to a half of that, give or take. I don't even have those stats, but it's a lot less than the speed of light. So yeah, that's been the goal. Hey, maybe we can process really, really fast. That's cool. Well, with quantum entanglement, that kind of turns the whole thing on its head, because now all of a sudden you can process instantly, and as fast as the speed of light is, it's a lot slower than instant. Once things become instant speed, then all of a sudden, the size of the chip no longer matters. You don't really need more power for it. In fact, the size of the problem really doesn't matter anymore, because now you're traveling at instant speed. And it used to be thought that information can't travel faster than the speed of light because the speed of light was thought to be the speed of causality. But through a series of experiments from various people and various platforms and different applications, we've found that it turns out information can travel faster than the speed of light, because it's not really traveling. I think that's what it comes down to. Things can't go through space faster than the speed of light, but if there's no traveling going on, then there's no violation to causality. Yeah, I'm not going to get too much into that. But yeah, there's a lot of concerns. The reason I'm excited is because this opens up vistas of computer processing, to an unlimited potential. A lot of people are concerned because the rise of quantum computers means that our entire encryption process is basically defunct. Most encryption is based on the idea that it's a mathematical problem that would take a standard processor, hundreds of years to resolve, whereas a quantum computer can just do it immediately. Kind of like if you've seen the movie Sneakers. Yeah, it's like that. But that's just the concern. I mean, obviously, if that is the case, we will have to move over to some kind of encryption process that isn't based on mathematics. I don't have any ideas on how to resolve that, but that's not what I'm talking about today. So I think there's a lot of debate about whether or not the D-Wave computer that Google has actually is a quantum computer, and then there's debate about the exact definition of a quantum computer. But I think that just the fact that we are aware of these things, to me, means that they're probably already in use by, large state actors like America, Russia, China, and more. And they're going to become more and more prevalent. But instead of being concerned, I mean, the ability of them to create virtual environments, to map out weather patterns, I mean, it's going to change everything. These huge algorithms problems that we've had trouble with before are all of a sudden going to become not as much of a problem. And so that's a lot of the reason why I think that it's really tied into the singularity. I'm not going to get into the singularity too much on this particular video. In fact, I'm almost done. I hope I did a good job of describing what quantum entanglement is and why I'm excited about it. So I'll catch you guys later. Thanks.